Good morning. So we are back today with 12-4 infinite sums. We're going to start with partial sums, which are parts of infinite sums. So these are kind of interesting because these can be used in order to determine trends. They will approach a certain limit, and that's what it is that we're trying to find. So if you look at what we have down here, we've got our normal infinite summation notation, which you know is an infinite sum because it has that little infinity sign at the top of the sigma. So like any other geometric one, and these are all geometric, this is going to be our first term, and this is going to be our ratio. Okay, so in this case, we know what our first term is. Our first term is going to be 100. And our common ratio is going to be 1/2. Okay, so this is how this works. What we're going to do is figure out what the first four terms are, and then individually we're going to add them up. Okay, so a sub 1 is going to be 100. We already determined that. A sub 2 is 100 times 1/2, so 50. A sub 3 is 50 times 1/2, so that's going to be 25. And a sub 4 is 25 times 1/2, which is going to be 12.5. Okay, so now in order to find the partial sums, we're going to take the first one, which is the sum of one term. Okay, the sum of one term means that we're looking at 100. Okay, the sum of the second term, or the sum of the first two terms, means that we're looking at 100 plus 50. So that one's going to be 150. Okay, then the sum of the first three terms is going to be 100 plus 50 plus 25, which is equal to 175. And finally, the term of the first four terms is going to be 100 plus 50 plus 25 plus 12.5, which is equal to 187.5. Okay, so S sub 1 is equal to 100. S sub 2 is equal to 150. S sub 3 is equal to 175. And S sub 4 is equal to 187. So when you find these, you're going to figure out what your first four terms are, or first five terms, whatever it is you're working with. And then, one at a time, you're going to add up those little groups. Okay, so then this is what we're going to be graphing. So we're looking at, let's see, our highest number is 187.5. So let's go by 50s. So 50, 100, 150, and 200. Okay, we'll keep it nice and round. And then we're adding up four different terms. So we're going to say S sub 1, S sub 2, S sub 3, and S sub 4. And I'll go ahead and mark those. S sub 1, S sub 2, S sub 3, and S sub 4. And actually it's just the term numbers, so 1, 2, 3, and 4. And then this right here is actually your S sub 1, S sub 2, S sub 3, okay, and that one's going to be 50, and then 100, and 150, and 200. Okay, so we've got our values right there. Okay, so S sub 1, our first term, is going to be 100, so we're going to graph that right about here. Okay, over 1 and up 100. S sub 2, so we'll go over to the second one, is going to be 150. So we're going to go over 2 and up to 150. Okay, S sub 3, which is the third term, is going to be 175. So we're going to go over to the third term, and we're going to go up to, which is right kind of between 150 and 200. Okay, S sub 4 is 187.5. So this is right between 175 and 200. So it's going to be right there. And you'll notice that it's kind of leveling off. It was going up a lot, and then a little less, and then a little less. And if we went a little bit farther, we would probably get another number that's not quite at 200. So we can say that this trend is approaching a limit of 200. So I'm just going to write approaches And actually I want S sub n approaches 200. And that's going to be my answer for this partial sum. So partial sums look at little pieces of a series at a time, an infinite series. And they look at infinite sums from a specific series. And then they compare them by graphing in order to see what that trend might be. Okay, and that's all there is to this. Now, sometimes as these go, they're not leveling off enough that you can tell exactly what it's approaching. So you may want to go ahead and do a couple more. So figure out what the 5th term is and the 6th term, and then figure out what the sum of 5 terms and the sum of 6 terms is. And a lot of times that's going to make it a whole lot easier to figure out what it is that you're actually looking at. Okay, now let's take a look at sums of infinite series. We have a summation formula for this one, and this one looks like this. The sum is equal to a sub 1 over 1 minus r. Okay, first thing you should notice is that there's no n attached here. That's because it doesn't have a specific set of terms, since it goes on forever and ever and ever. And the reason that we can figure this out is because there are a lot of things in Algebra 2 that are just plain magic. Okay, so there is a specific rule to this one. You have to use ratios that fall between 1 and -1. And so if we use some fancy schmancy math talk here, we can say the absolute value of 1, or of r, has to be less than 1. Okay, so in other words, 1/2, that works. -1/2, that works. 0.25 works. Negative 3/6 works. Okay, all of those are going to work because they're all less than 1 or -1. Or when you take the absolute value of r, it's less than 1. So if that's not the case, then the sum does not exist. So let's go ahead and put that down. Otherwise, the sum does not exist. And we're going to say DNE for short. Now, this is one of those things that you want to check right in the beginning, because you can go ahead and work this out with one that won't work, and you'll still get an answer for it. So this is going to be very important. So make sure that you take a look at your ratio first. Okay, because if it's greater than 1 or less than -1, then you are finished. You can write DNE and then you're done. Okay, so let's take a look at our first example of infinite sums. So as we're looking at this, we can tell that a sub 1 is equal to 40, and our ratio is equal to 0.2, which is like 2/10 or 1/5. So that one's going to work. So our ratio is 0.2. All right, now let's go ahead and set it up in our formula. So S is equal to 40 over 1 minus 0.2. Okay, which is equal to 40 divided by 1 minus 0.2 is 0.8. Okay, and we can simplify that further. You can do it on the calculator, 40 divided by 0.8, and it's going to tell you 50. And if you do that, you're going to have absolutely no idea why. So if you do it by hand, even in your head by hand, it's a lot easier to understand what we just did here. So 40 divided by 0.8, or 8/10. Okay, so 40 divided by 8/10, and we can reduce 8/10. 8/10 is also equal to 4/5. Okay, so 40 divided by 4/5 is the same as 40 times 5/4. Okay, so 40 times 5/4. Okay, so if we cancel here, then we are left with 10 times 5, which equals 50. And we got the same thing as what we got up there. Now, the important thing about this is that if you do this like this, you will some of the time be able to do this in your head. And even if you write this much out, it's still going to be faster than reaching into your book bag in order to get your calculator. Just pointing that out, which of course you can still use your calculator, but I am trying to sway you in that respect. Okay, let's look at example 3. So for this one, we are not given specifically a sub 1 or the ratio, but we can look at it and say that a sub 1 is equal to negative 6. Okay, and we find the ratio the same way we did yesterday with the geometric series. So we're going to say the ratio is equal to negative 12 divided by negative 6. Okay, negative 12 divided by negative 6 is going to be 2. 2 is greater than 1. Therefore, we're going to have to say that this one does not exist. And see, we did that right off the bat, and so we didn't have to do any more work. Okay, let's flip this over. Whoops, I missed one. My bad. Okay, let's take a look at example 4. All right, so this one looks a little dicey because we're dealing with fractions. So we know what a sub 1 is. A sub 1 is equal to 1/2. Okay, and we know what our ratio is, or at least we can figure it out. It's going to be 1/3 divided by 1/2. And if you do this on your calculator, of course, there is no way that I can know that, so you will get 2/3. But it's easier to do by hand, but I'm not going to force you to do that. Okay, so let's go ahead and set this up. Our first term is 1/2, so S is equal to 1/2 divided by 1 minus 2/3. Okay, so we have 1/2 divided by 1 minus 2/3 is 1/3. Okay, and I can't resist. I'm going to go ahead and flip and multiply. So we're looking at 1/2 times 3/1, which is going to be equal to 3/2. I'm sorry, but that is just quicker than putting it in your calculator, especially when you're working with fractions. Okay, so we got an answer of 3/2. Any questions? Okay, good. Then let's move on. Okay, rewriting decimals. Now, this is something that doesn't seem to have anything to do with this, but it actually kind of does, because there's a way to do this algebraically, and then there's a way to do this with series and sequences. And when you do this with series and sequences, you'll pick up real quick on a pattern that makes it easy to do this without even doing any math at all. So let's go ahead and look at this. We have 3 steps. Okay, the first thing we're going to do is take our fraction and rewrite it as a series of fractions. Okay, and you should probably write this down because I guarantee you won't remember it. So rewrite as a series of fractions. And we're dealing with decimals, so you're going to have to be able to change those to a fraction. Okay, then because we're using sums, we're going to find a sub 1 and our common ratio. And then last but not least, we're going to plug it in and simplify. All right, so let's take a look at this. Make sure you're pausing as we go if you're not getting all of this down. All right, so we're looking at example 5, which is 0.111111, pretty much forever. Okay, so if we look at this very first part of it, 0.1, that's going to be 1/10. Okay, then if we look at the next one, okay, without this one, so 0.1, because we already have this one, then it's going to be 1/100th. And if we look at the next one after that, we've already got these two, so 0.001, we're looking at 1,000th. Okay? So, first thing we want to do is figure out what a sub 1 is. Okay. A sub 1 is equal to 1/10. Okay, we got that. And our ratio is equal to 100th over 1/10. So a sub 2 divided by a sub 1. So 1 over 100 divided by 1 over 10. Okay, so I mean, this is going to be, when you simplify it all, we can cancel out our numbers here. And we've got zeros, and we've got 1/10 over 1. So it's going to be equal to 1/10. All right, step 2. Now we're on step 3. We want to plug it in and simplify. So S is equal to 1/10 divided by 1 minus 1/10 which equals 1/10 over over 9/10. 1 minus 1/10 is 9/10. Okay, so now we can cancel, and this right here, what I just did was 1/10 times 10 over 9. I flipped and multiply, and then I can cancel. And it works the same way when you're dividing if you just cancel the denominator. So I end up with 1/9. Okay? So we wrote it as a series of fractions. We determined our first term and our common ratio, and then we plugged it into our infinite sum form. This is so much easier than doing this algebraically. Okay, let's try another one. Okay, so the part that you're putting in fractions is going to be the repeating part. Okay, so with this one, we have 2 digits that are repeating, the 35. So when we figure this out, our series is going to be 35 over 100. Okay, so then those 2 would now be zeros, and it would be 0.0035. So now we've gone a couple places. So it's going to be plus 35 over 10,000. So you're adding 2 more zeros. If I add 2 more zeros to this, it's at 10,000. The next one would be at 1 million. However, I'm not really going to write any more than this because I only need the first 2 terms to find the ratio. I've got my first term here. And then this one divided by this one is going to give me my ratio, and that's really all that I need. So we've written it. Now we're going to say a sub 1 is equal to 35 over 100. And our ratio is equal to 35 over 10,000 divided by 35 over 100. Okay, so with this one, we can cancel out 2 zeros, and we can cancel out our 35s. Okay, so let me go back up here and show you how I did that. So we have 35 over 10,000 times, and now I'm flipping it, so it's going to be 100 over 35. So 100 over 35. So I can cancel out my 35s. I can cancel out 2 zeros, and I'm going to be left with 1 over 100. Okay? So, and I did that from here by canceling out numerators and canceling out denominators. And that's always going to work too, but only when you have stacked fractions. Okay, so let's plug it in. So I get S is equal to 35 over 100 over 1 minus 100, which is equal to 35 over 100 divided by 99 over 100. Okay, I can cancel out my 2 zeros, and I am left with 35 over 99. Okay, are you noticing a pattern here? Because we have a lot of patterns here. And if you don't get it, ask me about it when I come back and I will explain it, because kind of a cool pattern. All right, so example 7 is a little bit different than the other two, because not only does it have more than one repeating number, but we have a number in front of it. Okay, so the part that we're using as our first term is the first decimal part. So what we're going to do is kind of set the 21 aside. So it's 21 plus, and then it'll be 21 over 100 plus 21 over 10,000, just like in the last one. Okay, so this is what I'm going to use for a sub 1 and a sub 2. And then all the way at the end of the problem, then I'm going to add in this 21 into the fraction. Okay, so our first term then is going to be 21 over 100, and our ratio is going to be 21 over 10,000 over 21 over 100. Okay, so our 21s are going to cancel. I've got 2 zeros that'll cancel with 2 zeros here, and I'm going to be left with 1 over 100. And there is a pattern here, if you're looking. Okay, so now I'm going to plug those in. So we get S is equal to a sub 1, 21 over 100, divided by 1 minus 1 over 100. And that's going to be equal to 21 over 100 divided by 99 over 100. Okay, and we can cancel those out, and we will be left with 21 over 99. Now, the other two were simplified. This one is not. We can take 3's out of this one. So we're really looking at equals 7 over 33. Okay, now, remember I said that we still have to deal with this 21 at the end. So we're going to change this 21 into, because we've got 21 plus 7 over 33. So in order to combine that, we need to change that 21 into 33rds. Okay, so we're going to do that by multiplying it by 21. So we're going to say 33 times 21 equals 693. Okay, so this is 693 over 33. If you reduce it, you'll get 21. Plus 7 over 33, which equals 700 over 33, which I happen to think is very cool because it turns out like that a lot of the time. All right, so there's also a cute cartoon down here for you. Make sure you look at it. Not that it'll be on the quiz, but just for fun. And I will see you tomorrow. Bye.